amount of stuff you need to know. But the main idea, guys, is for you to be able to take a right triangle and find side lengths and angle. That's what you need to be pretty much focusing on for the entire week. Okay? Okay, so first thing, all right. These things that are called special right triangles, they're called that because when you have these certain angle measures pop up, okay, the sides are going to be in a ratio. They're a set ratio all the time. So that means that I can set proportions up to find these side lengths. And like I said, that's the main focus, is being able to take a triangle, a right triangle, and find side lengths. All right? And the reason is because every chapter after this, like the shapes we deal with, are going to be broken up into right triangles. Because of the fact that we do have tools to find side lengths for right triangles. All right? Now, and anytime I reference, guys, special right triangles, that just means that the triangles, the right triangles, have these specific angle measures in them. Of course, they have to have the 90 to make it a right triangle. All right? And the 45, 45, 90, you want to write it beside. I'll probably do it, I think, in a second, but that's also an isosceles right triangle, meaning that the two legs are going to be equal to each other. Obviously not the hypotenuse, that's the longest side. Oh, they don't still right now. No, sorry. Pretty much all this stuff's going to get confused, so if you don't write everything down, I'll confuse. And what we're going to do is we're going to go one by one, each one. Okay, with the 45, 45, 90 first, look at the ratios, so on and so forth. Close enough yet? No. All right, guys, let me go on. If I need to come back to this at the end, I will. All right, so first thing. All right, 45, 45, 90. Oh, man, I got to do it. So 45, 45, 90 is considered, like I said, a special right triangle because the side lengths are always in a distinct ratio. Okay, such as the two legs are always 1 to 1. They're exactly the same. Okay, they're always going to be the exact same measure because this is an isosceles right triangle. The longest side is always going to be scaled up by the square root of 2 by whatever the smaller side is. So the smallest, like they're the most basic 45, 45, 90 you would see. 45 degrees would be a right triangle with side lengths of 1 and 1 for the legs, and then square root of 2 right there. Okay, now every other 45, 45, 90 that we deal with is basically this triangle just scaled up or down by a certain factor. Like if I took all the sides and multiplied them by 4, it would still be a 45, 45, 90 right triangle. If I have one that said 4, 4, and 4 square root of 2, they're still 45, 45, 90, okay, because they're in a specific ratio. The whole idea behind these is that you'll get to a point where you should be able to do these problems fairly quickly using the idea that this is your base. Everything else that's a 45, 45, 90 is just a scaled up version of this triangle right here. Well, scaled up or scaled down. Okay? Now, when we do these, okay, and when I do 30, 60, 90s, like when I start them, I'm going to do them the longer way, using this ratio right here to set up proportions. All right, I'm not going to do the quicker way yet. I'll do that at the end. All right, so all the problems that we deal with in this realm of special right triangles will be based on proportions. Okay, doing the cross multiplying. All right, so just to show you, to show you what I mean by these proportions. Okay, this set ratio up here, right, the 1 square root of 2 thing, I tend to treat these as my numerators for ratios, like in terms of the proportion part. Okay, so I treat these as my numerators. The actual numbers and variables that are on the triangles is going to become my denominators. In terms of, again, setting up a proportion. Now, when you match it up, these sides, like the numbers up here in the base ratio, the 1 square root of 2, this is telling you that this one is opposite the 45-degree angle, that's opposite the 45-degree angle, and that's opposite the 90-degree angle. So that when you go to the actual triangle and match them up, you match them up in the same way, such as that side's opposite to 45, that side's opposite 45, and that's opposite to 90. So if I set up just ratios, like just fractions right now, I could do like 1 over 10, got 1 over x, I got square root of 2 over y. Right? The square root of 2 here is opposite 90, y is opposite 90. They make a friend. This x and that 10 are both opposite to 45, so there's 1. All right, and what you're doing is, look, since all those sides are in ratio, guys, all these fractions have to be equal to each other. So you can just mix and match them, all right, into proportions in order to solve it. Such as I can do like 1 over 10 equals 1 over x, and I can do like 1 over 10 equals square root of 2 over y. But when you match them up, you obviously need to have one side that has numbers on both top and bottom, or else you can't really solve these out. Okay? And then you would just go back cross multiply. I mean, matching these up is the first step. Throwing in into proportion would be the second, and then cross multiplying to solve them would be the last step. So if I cross multiplied here, that'd be x times 1, which is x. 10 times 1 is 10. So I know x is 10. Which honestly, guys, if you got a 45, 45, 90, you shouldn't really ever have to do a proportion for the legs, because you should remember that this is an isosceles right triangle, so these two are always going to be exactly the same. All right? For this one here, when I cross multiply, I got y times 1, which is y. 10 times square root of 2, which is just square root of 2. Because I want these need to be in simplest radical form. Don't multiply them out. The only time you might multiply them out is if it's like a real world word problem kind of thing. Then it would make sense to have a decimal answer. Okay? Otherwise, if you're just solving for side lengths, that's what I'd be looking for your x and y. Okay? Is that right so far? See a lot of this stuff coming up. Okay? Answers need to be this way. Alright? Move on to the next one. And then I'll do more in a little bit for both triangles. Alright, so the other one. Again, the main ratio. And this is treated the same way. That main ratio, guys, is taken from your base 30, 60, 90 triangle, which has the side that's opposite my 30 would be my shortest side that's got a 1 on it. Because again, the numbers are what's opposite the angle. 30, the 1 is opposite 30 degrees. Square root of 3 is opposite 60. And the longest side is 2. So every other 30, 60, 90 is simply this triangle right here. It's either scaled up or down. That's it. Okay? So if it was like twice as big, the size would be 2, 4, and 2 square root of 3. Okay, if it was half the size, it would be 1/2, 1, and square root of 3 over 2. Alright? Like I said, when you do these problems, guys, these numbers right here, this ratio, you need to know it, especially if you're doing these with proportions. Those are going to be the numerators. And then the numbers that are actually on the triangle we'll treat as your denominator. Okay? So in every problem, as soon as you see a 30-degree angle or a 60, and you know it's a right triangle, you need to resort back to doing it this manner. Okay? Even after we go through the stuff we do tomorrow. Because tomorrow you'll have other ways to find these side lengths, but these problems, guys, I always want the simplest route. Right? Can you go past this? I do. Okay, so it's going to be my one example I'll do. Okay? So again, just remind you, right? That ratio there, numerators, these 3 numbers here are going to be my denominator. Alright? What I would do is, if you're doing these problems, guys, I would go ahead and make the fractions first, so you can visualize them. So I got 1, I got square root of 3 there, and I got 2 on top. And then on the bottom is going to be whatever matches up to it in the actual triangle. So the 1 here has to be opposite the 30-degree angle. So opposite my 30-degree angle in the actual triangle is a 4. Opposite the 60-degree angle, I've got a y, so I just put a y there. And opposite the 90 is my x. Then I would just match them up. Okay, I would do like 1 over 4 equals square root of 3 over y. And 1 over 4 equals the rest. If I cross multiply here, I got 1 times y. I got 4 times square root of 3. That's what this side is. 3. Okay? Cross multiply again. You get x equals 8. You're done. Okay, note, Pythagorean theorems need to be involved, and nothing, guys. It's just going to be simple cross multiplication. Look, as of right this second, everyone okay where I got these from? Any issues with me getting the fractions, why I picked the numbers, why I put them where, anything like that? That's the key to doing this. If you can set those up, there's no reason for you to get or to not answer the question or get like an incorrect answer. Okay? Now the ones I've done have been most straightforward because I gave you the smallest size. All right, so far? All right, can I go past this? All right. I can do it again. We do like 2 more examples before I get to the short. All right, do one with 45, 45, 90, and then one with 36. There's X, there's Y, let's do 10. On the 30, 60, 90, do you want me to put the number on the longest side or the middle side? Longest one? All right, that's what you do. Give me a number. 14? Okay, 14. The 14, and then there's actually 1. Okay, now again, I'm going to do this in a longer manner. Like we could probably do these problems. If you got the shortcuts, I could probably get done with these in like 10 seconds. Okay? But for the sake of making sure, because some people, like I said, some people are going to get a little confused on the shortcuts and they're just not going to see what's going on, which is fine because you have the proportions to fall back on. All right, so what I would say you're doing, if you're going to do these in proportions, on the 45, 45, 90, and 30, 60, 90, I would first write out the numerators, which is simply the ratio. Okay, that's what you need to know, that ratio. Like the sides are 1 square root of 2 here. All right? And then below them, I would write what corresponds to it on the actual triangle, right? Because the numbers on the actual triangle, the x, y, and 10 are your denominator. All right, so what goes under these two? X and y, and that's your 10. So I get like 1 over x equals square root of 2 over 10. Do I really need to set the other one up? No, it's going to be the same. Okay. So if I do my cross multiplying here, what do I get? Like 10 equals like that. Then how do I get rid of that square root of 2? How do I move it to the other side so I'm just left with x there? What is this saying right here? This is saying x, is it x plus, x minus, x divided by, times what? So if I got something multiplied by x, how do I move it to the other side? Divide by it. That's fine. Okay? You guys can leave your answers that way. It's not technically fully simplified. This actually if you actually fully simplified this number, you don't want a square root in the denominator. Okay, so this actually, when you simplify it, if you've got a square root in the denominator, the way you get rid of it is you multiply the top and bottom by that square root, making it 10 square root of 2 over 2, which is 5 square root of 2. Honestly, right this second, for your answers today and stuff, I don't really care if you do the full simplifying. As long as you can get to this point here, that's fine. So if you put an answer of 10 divided by square root of 2 there and there, that'd be okay. Right? So that problem's done. The 45, 45, 90s are a whole lot faster than the other ones. They take less time. All right? So over here, the ratio for this was 1 square root of 3, 2. What goes below? What goes below the 1? You think? X. Goes below this one. Y. And there's. All right. In this case, there's no sides exactly the same, so you do have to do 2 ratios. 2 proportions. Okay, so if I do for x first, if I do my cross multiplying here, what do I get? 7. I get x equals 7. Is that okay for me to just jump there? You understand, right? 2 times x is 2x equals 14. Okay, so it's not a big deal. That's 7. All right. What about here? If I do my cross multiplying, what do I get? 2y. All right, so 2y equals 14 square root of 3. What would I do to get y by itself? Divide by 2, and this becomes. Okay? Alright, so that'd be doing the longer way. Let me do the shortcut this time. Okay? Before I do that, is everyone okay with how I pick these right here? The top numbers of the ratio I give you, the bottom ones you just match up from the triangle, guys. And it's always small, middle, long. Small, middle, long. All these are the same. Okay? Alright, so here's how the shortcut is. If you want to write out like a little kind of guide to it, that's what I suggest you write out. But the whole idea is that the 45, 45, 90s aren't that hard. Okay? Basically the way these goes is on 45, 45, 90, if you've got the smallest side, you multiply by square root of 2, you times square root of 2 to go over there. If you're going back from it, you divide by square root of 2. Like that's really kind of the shortcut there. Such as if I had this side, if this was my 45, 45, 90, and I said this side is like, I don't know, 7 or something. I automatically know that if I put an x and y there, these two are the same, so that's 7, and this is 7 times square root of 2. If I was going backwards from that and I gave you the longest side, you just do the direct opposite. You multiply to go to the longest. The opposite of multiplying is dividing. So if I put like 16 here, and I said these were 45, 45, 90, when I go backwards to it, I'm basically just dividing by it. That's it. Okay? Now, this one over here, a little bit more involved, because the main thing you have to remember is find the shorter side first. Because what's up there is all in relation to the shorter side. Okay, so the biggest thing you have to do if you're doing this with the shortcut is find the shorter side first. Alright? So from the shortest side, to get to the longest side, you divide by 2, or multiply by 2. If you're going backwards, you would divide by 2. If you're going from shortest to middle, you multiply by square root of 3. If you're going backwards, you do the direct opposite, you divide by square root of 3. Okay? And guys, answers can have square roots in the bottom, it's fine for right now. Alright, but if I had those two problems that I just did up there, portions, like I said, I probably could have been done in like 10 seconds, however long it took me to actually write the numbers out. It's pretty much how long it would take. Okay? Alright, let me do something real fast. I think I got it there. Can I go past this? Yeah? Yeah? Alright, so here's something. We'll do them quick. Actually, we'll do these. Alright, and I'll probably make up some. We'll be pretty quick. Okay, so starting with this one over here. Like I said, on the 30, 60, 90s, guys, find the shortest side first if it's not there. Like here, they start you with the longest side, so the first thing I would do is find that side. And by the shortcut way, you say, if I got the longest side, to go to the shorter side, you just cut it in half. What's half 6? 3. And to go from shortest to middle, you just throw away square root of 3 on the end. Done. Okay? Alright, so I did 8. I've got the shortest side here. I know it's the shortest because there's my 30-degree angle that's opposite to 30. So to go to the longest side, double it. 12 times 2. And to go to the middle, you just do that times square root of 3. You're done. Okay? This one here is 45, 45, 90. I've got the longest side.
Oh, yeah, no.
Ratio is 1. Okay? So, in a 45, 45, 90, if I go from longest to biggest, I would divide by whatever the square root was. The square root in 45, 45, 90 is the square root of 2. Let's divide by square root of 2. That's it. Because I don't need to simplify. If you did simplify that, it becomes 6 square root of 2. Okay? Let's see. We'll do on the middle. We haven't done with the middle yet. On 30, 60, 90. Just give me a number. 12. 12? Sure. 12. Okay? So, if I gave you this and I said, all right, find x and y. And again, I'm doing it shortcut. I'm not doing proportion. To go from small to middle, you multiply by square root of 3, so that means going backwards, I'm going to divide by square root of 3. And then once I know the shortest, because I would always find the shortest first, and once I find the shortest, I would double it to go up to the longest side. If I double that number, what do you think it becomes? 24 divided by square root of what? 3. The root didn't change. Only doubling the regular number. Nothing else doubling. Alright? Do these all day. Do these no time at all. Short, middle, or long? You know one.
Short.
Short? What number?
7.
7 or 18? 18, sure, 18. Alright, so if I give you, here's another 30, 60, 90. Shortest side is 18. What's the longest side?
30.
Double it, which is 30. And then, will you multiply by to get the other one? 18 square root of 3. Done. Okay? Do another one? They take like 2 seconds, honestly, they don't take any time at all.
Can you do the other one?
Which one?
The middle one.
Do the middle one, the 30, 69? 30, give me number 28. 20 what? 28. So middle side is 28. So I would always find this side first. This is 28 divided by 3. And multiply it by 2 to get over there, it's 28 times 2. 646. Easy? It's easy if you get this. It's not a big deal.
I like the longer way around it.
That's fine. I don't care. You get the right answer, you get the right answer.
So,
Okay.
like the straightest triangle is the half of the top.
Yes. Okay? All right. If you can do it this way, like I've done a few in a row, guys, if you get the pattern, if you understand what's going on there, it's going to be a lot quicker, obviously, to do it this way. If you had no clue what I just did, do the proportion. Then change your answer one bit. Which means you take a little bit more time. It doesn't really take that much longer to do the proportion, but it does take a little bit. Okay? But guys, all your answers here, from now on, if you see 30, 60, 90s or 45